Let's continue with this book on data mining by Pang-Linh Tan, Michael Steinbeck, and Vipin Kumar. So it's a book on data mining, of course, and it's a rather introductory book. It even deals with what is data mining, types of data, data quality, and what does it do? It does data exploration, data classification, decision trees, model evaluation, nearest neighborhoods, classifiers, and so on, association analysis. It does things like cluster analysis, anomaly detection, and yeah. So it's a fairly introductory book, and it will teach you everything you need to know to be able to start doing actual data mining on some things. It does the basic techniques, and it shows you the basic math, but nothing too advanced. I think it's a fairly good book that's introductory, and I think if you want to get into data mining or get some experience or have some questions and you really want to get first ideas in, this is a good book. So yeah, if you want an introductory book on data mining and everything, I would definitely recommend this. Next is a graduate book on Shiryev on probability. So it's a graduate book on probability, which means it's fairly advanced. It deals with elementary probability theory, mathematical foundations of probability theory, meaning Lebesgue integral, random variables, convergence of probability measures, central limit theorem, sequences and sums of independent random variables. It deals with stationary ergodic theory, martingales, Markov chains. So it's a fairly advanced book on probability theory. I think it was kind of a run-of-the-mill graduate textbook. I didn't think there was anything too special in it, or anything that really attracted me a lot in it. I would not buy this again. I would not work through this again. I didn't think the text was as careful or as interesting as I thought it would be. Here we have a book on designing experiments, planning, analysis, and optimization by Wu and Hamada. So it's introductory, or it's a very advanced book on experiments and how we design experiments. So we have experiments with a single factor, we have more than one factor, we have full factorial experiments with 2 levels, fractional factorial experiments with 2 levels, full factorial and fractional factorial experiments in 3 levels, and it really goes on. Non-regular designs, complex aliasing, response surface methodology, introduction to robust parameter design, and then experiments for improving reliability and analysis of experiments with non-normal data. I bought this for a course on experiments and how to arrange experiments, and I think the book is kind of out of date. So I don't think we really do things like this anymore. They are way more advanced and way more neater linear algebra methods that we have these days, but I'm not sure I know any good book on it. If you want to know things about factorial designs or stuff like that, which I think is quite outdated, then I would recommend this book, but probably you shouldn't do this book. Here we have a book, Statistical Decision Theory and Bayesian Analysis by Berger. As it says, it's a basic book on statistics and decision theory. It starts off with utility and loss prior information, so it goes right into the Bayesian framework. So Bayesian analysis, minimax analysis. It does things like invariance, pre-posterior and sequential analysis, complete and essentially complete cases. So this is a fairly theoretical book on Bayesian methodology and Bayesian statistics. If you want to know the foundations of Bayesian, if you want to know what Bayesian statistics really says in depth and mathematically, I would highly recommend this book, even though there are other ones that are equally as good. I did not manage to read this myself, so I don't think I can say much about it. Here we have Rindler, a very famous relativity writer, and he has a book on special, general, and cosmological relativity. He has quite a few very interesting books and well-regarded books, and they are, always really recommended. So we start here with Introductory to Relativity and the Galilean relativity and how Michelson-Morley experiment and how everything fits together, and they go quite straight into special relativity, the kinematics, the optics, form momentum, particle mechanics, electromagnetism. Then they go towards general relativity, and they do all the themes necessary for general relativity, including the Schwarzschild metric, black holes, the Sitter space, and then it goes into cosmology. So yes, very famous book. I think there's a lot in this book that's not in other books. I originally bought this book though because I wanted to know more about rotation in relativity, and I did not really find this here. Nevertheless, I think there are better books on the topic, but still it's one of the better ones. It's definitely one that is very interesting. But there are many other books on the topic, so not necessarily one you should be reading. Next, the book I regret buying the most, this crap. I'm not going to mention it even because, yeah, I mean, it's basically Hossenfelder who whines about math and physics. Here we have Van der Vaart's asymptotic analysis, statistics. This is a fairly theoretical book on statistics and statistics of large numbers. So you see already here that it starts basically with the O symbols, almost sure representation, Lindbergh-Fuller theorem, delta method. So this is a fairly advanced mathematical book and a very mathematical treatment of things, of statistics of large numbers, what happens to tests when the numbers get high. Very much a book that I would recommend. If you are into statistics from a more rigorous point of view, if you want to know why statistics holds in the first place, and if you want no rules barred on maths, like you want the most mathematical, well, maybe not most mathematical, but if you want a fairly mathematical point of view, this really is a book you want. This is a very, yeah, it's a famous book. It's a book that everybody knows. Everybody recommends. I highly recommend it as well. It has everything. It has everything you want from a point of view that you would really like. Then we come to Gibbons and Chakraborty, Non-Parametric Statistical Inference. This is my favorite book on non-parametric statistics. Meaning there's no distribution, there's no density, you basically derive it from scratch. And it does order statistics, quantiles, coverages. It does a test of randomness, goodness of fits, one sample and paired sample procedures, two sample problem. It has linear rank statistics and general two sample problem, linear rank tests, tests for the equality of k distributions, measures of observation, measure of association, asymptotic relative efficiency, analysis of count data. So very comprehensive book on non-parametric statistics and how to do non-parametric statistics. Contains everything you want in a level of detail that's, I think, really suitable for the topic, meaning not too big, not too little. I like this book a lot. I learned a lot from this book. I think it's been a long time ago since I've read it, though. So I forgot a lot too, but I think this is a very good book on non-parametric. My favorite book on non-parametric would definitely be this. Next we come to another very nice book, Numeric Analysis for Statisticians by Lange. which, as it says, is basically a numerical book on how to do numerical stuff. So it does recurrence relations and how to solve recurrence relations, power series expansions, continued fraction expansion, asymptotic expansions, solutions to nonlinear equations, vector matrix norms, linear regression, eigenvalues, eigenvectors, singular value decomposition, splines, optimization theory, the MM algorithm, the EM algorithm, Newton's method in scoring, local and global convergence, advanced optimization topics, concrete Hilbert spaces, quadrature methods, Fourier transform, generating random deviates, Monte Carlo methods, permutation tests and the bootstrap, finite state Markov chains, and yeah, Markov chain Monte Carlo. If you are a statistician and maybe not a mathematician and are interested in where do things come from and how do I compute things, like you can define your test, but you still need to compute your test. You still need to compute certain stuff. I think this is an excellent book. I think this is definitely a book I would recommend if you're more into the mathematical theory and more into, for example, proofs, or into stuff like, more mathematical topics, or maybe even numerical analysis for differential equations and stuff. This is not a book. This is purely for a statistician and for a statistician audience. Here we see Savage, The Foundations of Statistics. Quite a small little book on statistics. It's a Dover book, so it was very cheap. And yeah, it basically is a personal view on statistics. It does a very old view. I'm not sure why I even got this book, but yeah, I don't think I remember having this book. Yeah, I can't really comment much about it since I don't really remember much about this book. It seems like it's fairly philosophical, and it's has some comments on how to think of statistics and how to think of probability, as opposed to just giving formulas to memorize. This really tells you the why. That does seem like the case, but yeah, can't comment much on the book. Here we have a book on robust statistics by Huber Ronchetti, which is basically a book on statistics that says that when there are outliers, your statistics get skewed and your measurements kind of get wacky. So how do I prevent outliers from ruining my statistical framework? And as you see, the book is immediately rigorous, mathematically rigorous. It has the weak topology and metrization. And yeah, so not for the feeble-minded, or not for the person with weak math. It does everything very mathematically, and I think very interestingly. Definitely not for the practitioner, but if you want to do research in robust statistics and basically want to see the modern methods used, this is the book. But yeah, it doesn't hold back. It's open subsets, it's mathematics here and there. This really is mathematical statistics. Mathematical statisticians will love this book. The usual statistician and the usual person will absolutely hate this book.